All right, good afternoon, grade nines. I hope that you guys are all doing well and that you guys have had a productive Tuesday so far. Guys, we're back again for week 16 of tutoring. Um, as you guys know, we're making some pretty good progress through your syllabus for the year. We're back again, and today we want to discuss the world of geometry a little bit. We've been discussing shapes in a fair amount of detail, talking about how we calculate perimeter, area, surface area, and volume too. So, given that we've just come from dealing with these 2D and 3D shapes, it feels only natural for us to move on to talking about the properties of different shapes that we know of, the properties of our regular shapes, because we're obviously going to use all of this information in our geometry. Now, we're not starting with geometry today specifically in the sense that we're going to be calculating missing angles and such, but I do need us to go through the fundamentals of discussing the properties of different shapes. And something that I want to make sure to point out to you guys today is a lot of the wording that we use in the world of geometry, um, grade nines. For example, when I talk about diagonals bisecting one another, a lot of students aren't quite familiar or aren't 100% sure what the word bisecting means in that context, right? So even when I decide I want to study the section and I go into my textbook and I see that we are discussing, um, the properties of different shapes, when I read these words like bisecting diagonals and similar triangles and such, it can get a little bit confusing. So that's what I want us to talk about today, guys. I am going to already start by sharing my screen with you, and then we'll dive into today's work. So please just give me a second to quickly do that. If you guys have any questions, you're more than welcome to ask now already. And please remember that you're more than welcome to ask questions at any point during today's session. I'll answer them as soon as I see them in the comment box. Okay, and it doesn't matter whether you are watching on Facebook or on YouTube. I'll keep my eye out for any questions that you guys have. All right. So let me start by sharing my screen with you guys. Just a second. All right. So, guys, the shapes that we really need to understand quite well are unsurprisingly the three major categories of shapes, right? We've got to make sure that we understand our triangles, our quadrilaterals, which is bigger than most people care to consider, and obviously our circles as well. So today is going to be about going through those fundamentals. Next week, when we have our next session, everything that I talk about and the words that I use make sense, enough sense for you to follow along with the next lesson. So, um, we're going to be talking about the properties of 2D shapes today, and we're going to go into a little bit more depth than you might usually go into. Sorry, guys. If you hear me coughing or anything like that, I do apologize. It's just because I've been a little bit sick lately. So I hope you'll just bear with me in that sense. So we want to go through the properties of 2D shapes, and there's, like I said, three major categories that we want to discuss. We're going to go through triangles, which offer a lot of information about obviously the properties of the different kinds of triangles themselves, but also how we understand angles in the context of these different triangles. Number two, we want to go through our quadrilateral, which I also suspect will take us a fair share of time. And finally, guys, if we do still have a little bit of time left over, I will speak to you guys about circle geometry. Uh, and I mean by that just to talk about the different parts of a circle, right? So the difference between secants and major arcs and sectors and all of that information. So let's get going straight away with triangles, guys. I'm not going to make you wait any longer than you have to. I know that you guys are here. Uh, so even though I would usually give everybody a few more minutes to join, I'm just going to get started with today's work. Please remember that if you have any questions, you are more than welcome to ask. Let's begin with the world of triangles, guys. Right. The first kind of triangle, again, I think it is important that you guys are familiar with these triangles. But if you don't know all of the information that I'm discussing, I would recommend writing it down. The first kind of triangle that we have is called an equilateral triangle. Sorry, guys, just a second. I just want to draw these accurately. So we've got an equilateral triangle. Then we have what we call an isosceles triangle. And yes, you guys do need to know the names of the different triangles. That is important, right? So we have equilateral, isosceles, and finally, the misfit of the group, what we call a scalene triangle. So we need to know not only the names, but more importantly, the features or properties of the different triangles, because these are used on a consistent basis in the world of geometry. So if we don't understand these three, we're going to have a tough time understanding the geometry itself. So the first kind of circle, listen to me. The first kind of triangle is what we call an equilateral triangle. Second, we have an isosceles triangle. And finally, the third is a scalene triangle. Now, there is a lot for us to understand when it comes to the properties of triangles. When we discuss the first kind of triangle, equilateral triangles, we need to know its defining features or properties. Equilateral triangles, all angles are equal in size. I would recommend you guys use color for this section of work if you can. Okay, all angles are equal in size. Secondly, all sides are equal in length. And you guys should know by now that the internal angles of a triangle, the internal angles add up to 180 degrees. The internal angles of a triangle must always add up to 180 degrees. Right, so these are the features of our equilateral triangle, and they can be represented in the visual format as well. To show that all three sides are equal, we use a single line on all three sides. This shows us that all three are equal in length. And we do the same with our angle markers, right? We would say this angle is equal to this angle is equal to the third angle. All three are equal in size, which is why they have the same marking. Second, we have isosceles triangles. Isosceles triangles. What are the features of these triangles, guys? These are the ones that probably pop up in geometry the most. The two base angles, or let's rather say that we have two angles equal in size, and there are two sides equal in length. Right. Two angles equal in size and two sides equal in length. Again, as it is the case for all triangles, regardless of their style, the internal angles add up to 180 degrees. Now, we will discuss external angles in a second, but again, we can represent this information visually in a diagram. Now, it's usually going to be the two sides of an isosceles triangle that form the peak that are equal in length. So we will show that these two sides are equal by using the same marking on both lines. Now, a lot of people like to think of these as arrows because they point to the bottom left and bottom right, because we need to remember that these two sides at the base, the two angles at the base, are the angles that are going to be equal in size. The third angle at the top will be different, and the length of the baseline of my triangle will also be different. Okay? So the major feature of an isosceles triangle is that there are two sides equal in length and two angles equal in length. Now, the triangle can look a little bit different, but it's always going to have the same features. So we just have to practice spotting this information. Next, we have a scalene triangle. Right. Please make sure that if you guys don't know any of this information, that you are writing it down. Right, a scalene triangle, the third kind, the misfit of the bunch. Do these triangles have their own category? Because scalene triangles have three sides of unequal length. Right? In other words, all three sides of a scalene triangle are different. These are the triangles that really do not benefit us at all in the context of geometry. The same is true of the angles. Three angles of differing sizes. So when it comes to marking this on a scalene triangle, we really don't need to add much, right? Because all three sides are different and all three angles are different too. So there's not really much for us to go and actually fit on the scalene triangle visually. Now, some teachers will often say that there's a fourth type of triangle, which is your right angled triangle. And this is absolutely true. Okay, so we can actually go ahead and also discuss this as fourth Whether or not your teacher considers it to be a fourth kind of triangle is probably up for debate, but let's discuss it in any case. Right angle triangles. Now, when it comes to these triangles, they are very important in the world of geometry. And believe it or not, if you guys decide to keep up with maths for next year in grade 10, you will see how important these triangles become because they are the foundation of trigonometry. So, what's unique about our right angled triangles? First, there is one perfect 90-degree angle. Right, it is true that there will be no sides equal in length, and there are no angles equal either. So there are no angles equal in size. Now, you guys will have started learning about the theorem of Pythagoras, which is important and relates to right angled triangles only. So let's quickly draw a right angled triangle so that we can label some important information on it. I'm not going to go through the theorem of Pythagoras today. That is a separate lesson on its own, but I will give you the basics very quickly. When we look at a right angled triangle like this, it's no surprise that we have a right angle. The other two angles in this triangle are going to be different in size. They will not be the same value. That is impossible. All right? Okay. The side opposite our right angle is known as the hypotenuse. This is important for the theorem of Pythagoras and also for trigonometry next year, so make sure that you are comfortable with it. All right, so these are the four kinds of triangles that we must be comfortable and we must understand. These are the properties, and remember, again, we can actually add this on. I apologize, guys, I missed it under scaling. The internal angles add up to 180 degrees. It is the same for right angled triangles as well. Any triangle must have a total of 180 internal degrees. All right. Now, we're going to quickly discuss the concept of an exterior angle. Again, I'm not going to go into this in depth because we'll practice this as soon as we start doing a bit more of a deep dive into the world of geometry. But what do we need to know about external angles? Just write this as a note at the bottom, please, and I'll give you one example. Right, the rule is as follows for those of you that don't know. The exterior angle of a triangle is equal to the interior opposite angle of that triangle. Now, as you guys know, when it comes to the world of geometry, we are very fussy about our reasoning. Now, to write this sentence out over and over again does get a little bit irritating. So, we do have a shortened version when we need to write it down as a reason. We say that the external angle of a triangle is equal to the interior opposite angle. Okay, that is an official reason that you can use in a test or an exam. And I'm going to quickly draw a diagram to show you guys how to visualize this sort of concept. Okay, sorry guys, just a second. If you guys have got questions, please make sure that you ask. Sorry guys, I did make a mistake. I apologize. I just need to quickly rewrite part of this definition. I was thinking in terms of quadrilaterals, not triangles. Sorry, guys, that's on me. I apologize. The external angle of a triangle is equal to the sum of the interior opposite angles. Sorry about that. I thought something looked a little wrong with the definition. So, again, if we write this in a shorthand form, the external angle of a triangle is equal to the sum of the interior opposite angles. Apologies for that, guys. So, again, if we draw this into a diagram, you'll see exactly what I mean. Let's say this is an example of an equilateral triangle. So we have 60 degrees in all three corners or all three angles, and you are asked to identify angle X, which sits on the outside over here. Right. You would be able to say that this external angle on the outside of a triangle is equal to the sum of the two interior opposite angles, right? So in this case, that angle X that we see on the outside, same as 60 degrees plus 60 degrees, which gives us a total of 120 degrees. And that makes sense, guys, because looking at the angle on the outside, this is an obtuse angle. And again, the reason that you would use for this is that the external angle of a triangle is equal to the sum of the interior opposite angles. Right. So please keep that in mind when it comes to working with triangles. That is a very important piece of information to keep Right. So this is what I need us to understand as far as triangles are concerned for this lesson, guys. Now, I do also want to quickly discuss one or two of the quadrilaterals that we need to know. If you guys have any questions, please make sure that you ask. Apologies for the little mistake I made earlier. Right. So this is, for example, our external angles of a triangle. Next, we want to talk about quadrilaterals. Right. Just like we need to understand our triangles, there are a whole bunch of quadrilaterals that we also need to familiarize ourselves with in order to be able to complete questions in geometry effectively. Okay. I'm going to try and leave that on the screen for you guys to copy, but let's quickly start by defining quadrilaterals. Any quadrilaterals are any four-sided, four-angled regular shapes. Just for the sake of this discussion. So there are a few, we might not get an opportunity to go through all of them, guys, in which case we will have to just finish discussing two or three of them next week. Okay, but we've got squares, rectangles, rhombi or one rhombus, many rhombi, parallelograms. Finally, trapezium and a kite. So these are the six shapes that you're going to come across, guys, in tests and exams most frequently. Of course, there are other shapes that you could possibly run into. It's just definitely not as likely. So we want to make sure that we are familiar with the properties of all six of these shapes so that when we get into tests and exams, when we see that we've been given a question that is incomplete in terms of its information, we are able to make deductions and complete the information on our own based on our understanding of the properties of these different shapes. All right. Again, we'll go through them one by one. We are halfway through the lesson, guys. Remember, if you have questions, please ask. I'm more than happy to answer them. Now, this is where I want to talk about all of these different words that get a lot of people quite confused. What are diagonals? What does the word bisect mean? Right? We need to also discuss things like sides that are parallel. We need to know the symbol for parallel sides and the shape. And there's a lot more, but we'll get to discussing this as we go. So let's start with the very basics. We'll begin with shape number one, our square. What do we need to know about our square? Well, we have four equal sides and four equal angles. four equal sides and four equal angles. That's the easy part. What about the diagonals of a square, guys? Sorry, guys, just give me a second. Four equal sides, sorry, and four equal angles. We then have two pairs of parallel sides. And again, this is what becomes important for geometry because it allows you to quote unquote read between the lines, right? Two pairs of parallel sides. Diagonals bisect. Diagonals bisect one another. We'll talk about what that means in a second. I'm going to draw it onto a diagram. They bisect one another, and diagonals are perpendicular. Right. So, what does this look like in a diagram format? Let's quickly draw a square and fill in the information. Here's our square over here. We know that all four sides are equal in length, so we can use the following marker, right? One line on all four sides of our square tells us that they are equal in length. So we know that. We know that all four corners carry the same angle. All four corners are 90 degrees. We also know that the left-hand side and the right-hand side are parallel, meaning that they remain the same distance apart from one another indefinitely. So here you see that I use one arrow for two sides, and then I can go ahead and use two arrows for the second set of parallel sides. Right? So just please pay attention to when I use one arrow and two arrows. When you see multiple arrows, it generally means that we have multiple sides that are parallel to one another. And finally, the diagonals bisect. What are diagonals? Lines that stretch from corner to corner. So if I have, okay, let's leave this over here. I'm going to draw a second square very quickly. Right. When I talk about diagonals, like I said, is referring to the lines that stretch from one corner to the opposite corner of the shape. Now, when we say that diagonals bisect grade nines, please understand that that is a word that is used incorrectly a lot of times. When we say that they bisect, we mean to say that the diagonals cut each other in half, meaning that if I have four corners on this shape over here, A, B, C, and D, my but sorry, my diagonal AD, the yellow line over here, cuts the other line into two equal pieces, not into a 60-40 ratio, into a 50-50 ratio. And the same is true when we work in the opposite direction. If I now decide to focus on this line, line CB or BC, it cuts my yellow diagonal perfectly in half. So it cuts the pieces of the diagonal equally. All right. And lastly, when we say that they bisect perpendicularly, we mean to say that at the center here, where these lines cross, they form a perfect 90 degrees. They don't slant off at other angles, they cut through one another at a perfect 90 degrees. Okay, I hope that that makes sense, grade nines. This is theory that you guys really have to understand. All right. Uh, I'm going to leave these over here to the top right. If you need me to come back to them, please let me know. Shape number two, we need to discuss a rectangle. What do we need to know about rectangles? Again, there are specific properties. It's no surprise that the basic properties are obvious, right? We know that um, we know that opposite sides are equal in length. So the left-hand side is equal to the right-hand side, and the top is equal to the bottom side. Opposite sides are equal in length. We have four equal angles, and we know that they are all equal to 90 degrees. What else do we know? Just like a square, we have two pairs of parallel sides. The symbol for which is conveniently two slanted lines. Right? Now, what about these diagonals that we've been discussing? The diagonals also in a square bisect one another. Bisect does not just mean slice into one another, it means that they cut each other exactly in half. The diagonals bisect one another. Okay? But importantly, the diagonals are not perpendicular. Okay? Please remember that you must know the symbols for parallel and perpendicular. Right? The symbol for perpendicular is this in brackets. So we have the symbol for parallel and the symbol for perpendicular. Okay. Now, guys, if I had to go through every single shape and draw these features onto a shape, it would take me quite a while. And the goal is not for me to do every single shape like that, but rather help you understand these words. So, again, just very quickly, I will do it for rectangles, but I will not do it for the remaining shapes that we discussed today. Right. If I look at these rectangles, I know that opposite sides are equal in length, so I may mark the top and the bottom as equal in length, and the left and the right hand side is equal in length. The reason why we use two lines on the left and the right is because if I put one line on all four sides, that would be telling me that I have a square, which is not true, right? We know that opposite sides are parallel. So the top is parallel to the bottom. We also know that the left is uniquely parallel to the right. Okay. And guys, just pay close attention to how I use two markers for length and two markers parallel at the same time. I use one mark for length and one mark for parallel on the opposite sides. And we already know that the four angles inside of a rectangle all measure 90 degrees. Okay, so that is the first way we represent some of the information. As for the diagonals, if we connect opposite corners of my quadrilateral, of my shape, we see that these lines do in fact cut into one another. But again, the word bisect doesn't just mean cut or slice. It means that it does so into perfect halves. So the two sides of this diagonal are equal in length, and the two sides of the second diagonal are equal in length. But importantly, if we had to zoom into the center over here, where these diagonals bisect one another, we can see that it does not form a perfect 90 degrees, right? They are not perpendicular. They do not make a perfect 90 degrees. We have acute angles on the left and the right in this case, and we have obtuse angles on the top and on the bottom. All right. So now you guys know what diagonals are and what we mean when we talk about diagonals bisecting one another, and what we mean when we say that diagonals are perpendicular or not. So these are the two most basic shapes, but it's clear now that there's a lot to understand beyond just the sides of the shape and the angles of the shape. There are other elements at play. Why is something like this important, guys? Let's say, for example, I duplicated this shape over here. Right. If I get rid of all of this information very quickly, if I'm busy working on some kind of question relating to geometry and I'm given certain angles but not other angles, if for some reason I'm given the diagonals of a rectangle, I know that all four of these lines are equal. What does this tell me? I now have four unique isosceles triangles, right? This rectangle is split into four triangles, each of which are isosceles. So that's how we find these angles that are in really weird places, right? Triangles have got nothing to do with rectangles, but in the context of these diagonals, we can see more information than that might be obvious at first. Just consider this, okay? Four isosceles triangles, right? That's a hint for when we do geometry at a later stage. This is why your understanding of these properties is so important. And yes, I know it's not the most exciting thing in the world, right? But this is where distinctions are made. Do we have any questions so far, guys, about any of the words that I am using or the diagrams that I am drawing? Okay, I haven't seen any questions yet, so I'm going to assume that everyone's fine for now. Guys, we've got just over 10 minutes left, and this is everything that we already need to know about squares and rectangles. There are still four more shapes, but in the interest of time, let's discuss squares and rhombi very quickly. These two shapes are linked because a rhombus is essentially a square that somebody has sat on to make it slightly skew, right? A rhombus is essentially a square, a skew square. Okay. Then, when we think about a rectangle and a parallelogram, these two are also quite similar. There are some unique features that you guys will have to do on your own, but you guys now have a rough idea of all of the words that we use and what they mean. I want to talk about the shapes that are not so obvious very quickly. I'm going to try and leave this on the screen for you guys to copy. But let's jump ahead to number 5 and quickly talk about a kite, because a kite is quite a unique shape. Let's go ahead and draw them very quickly. Right. This is an example of a kite, guys. And again, there are some unique features that we've got to discuss. So, what are the features of a kite that we need to be aware of? Again, guys, this is going to take a little bit of work from your side. You'll need to go through one or two shapes on your own. Somebody's quickly just mentioned that they don't understand what the word perpendicular means. So let me just quickly explain that before I move on, because that's quite important. The word perpendicular means the two lines meet at 90 degrees. Okay, two lines meet at 90 degrees. So this is what we talk about when we see a corner, for example, right? Let's just say I have a line over here and a vertical line that's exactly 90 degrees on either side, right? If we see this and we have 90 degrees on the left and 90 degrees on the right, we would say that these two lines perpendicular. So let's say we have line A, B, and line C, D, right? Just an example. In this case, we can say line AB is perpendicular to line CD, right? They are perpendicular because these two lines, the independent lines on their own, AB, which we see across the bottom, and CD vertical, come together and meet at 90 degrees, right? So the way we would write this in shorthand, in geometry code, in other words, is to say AB is perpendicular to CD. So when we talk about diagonals bisecting, perpendicularly, right? For example, when we look at the square over here, these two lines that we see, CB and AD, come together and meet at a perfect 90 degrees. So we say that these diagonals are perpendicular. All right. I hope that that makes a little bit more sense. Let me know if it's still confusing you. All right. Let's quickly chat about a kite, guys, and then the rest are going to be for you guys to try on your own. Unfortunately, this is actually a lesson that would normally take longer than just 1 hour. So let's discuss the properties of a kite very quickly, and then we will be done. First things first, the two top parts of a kite are equal in length, while the two bottom arms are also equal in length. So, what does this mean? It means that we can say we have two sets of sides that are equal in length, right? There is one set of equal angles, and it's always the two sides where the two different length sides meet, right? So, property B is that there's one set of equal angles, which we've now marked on the diagram. So that talks about the sides and the angles. What else do we need to know about? Well, we need to know about the diagonals. First things first, the diagonals have different lengths, right? They are not the same length. It's clear that if we had to draw diagonals into the shape over here, remember a line connecting the opposite sides of a shape, vertical line is quite long in comparison to the horizontal line. So these two diagonals are different in length. The diagonals are perpendicular. Again, what does this mean? That the two diagonals that we see inside the kite meet at a perfect 90 degrees. Right? And what does this do? Again, these diagonals then split a kite, which is quite a unique shape, up into four right angle triangles. Right, the diagonals split the kite up into four right angle triangles. And again, this is really helpful to know when decide to step into the world of geometry, because it gives us a different way of looking at the shapes that we are working on. Not a lot of people instinctually think of four right angled triangles when they look at a cat. But again, it can be put down into such a manner. Okay, so guys, 4 minutes left, and instead of trying to cram more shapes that might confuse you guys, I want to quickly show you um, iRainbow, because on iRainbow there's a really useful document that you guys can use to also look at the properties of the remaining shapes and then test yourself on it. Okay, that'll give you an understanding of how well you know this work, so that as we step into geometry, in the coming weeks, uh, you will have a grasp on all of the basics. Okay. I'm going to give you 1 minute to quickly finish copying what you see on your screens now, and then I'm going to change to quickly show you iRainbow, and then we're going to be done for the night, guys. I recommend you just stick around for the last 2 or 3 minutes so that you can see exactly what documents I'm referring to. It's only 3 minutes. Okay, quickly finish copying, guys. I'm going to change screens now. If there's any other questions, please make sure you quickly ask so that I can answer it now as the lesson is ending. Right. So let's quickly go and take a look at these or this individual document that I'm trying to speak of. Right. So grade nines, when you guys open iRainbow, first things first, please make sure that it is updated, that you have access to all of the latest videos, quizzes, and just general functionality updates. But as soon as you open it, you guys will select mathematics, and we're going to go into the topic of space and shape, which is the second topic in the left-hand column. We will click on this, and then we want to go into the geometry of 2D shapes. We're not talking about 3D shapes just yet, right? Click on 2D shapes, and here is a lot of information that you guys can go through. Now, we haven't been through all of it just yet. We have chatted about the properties of triangles and the types of triangles, right? The first two. We mentioned very briefly the outside angle of a triangle, which you guys are more than welcome to go and just take a look at, read the documents, and even try the quiz if you'd like. But then over here, guys, the second topic in the right-hand column is properties of quadrilaterals. If I click on this one just for now quickly, I'm greeted by a document that talks about the properties of quadrilaterals. Right? So here are those 6 quadrilaterals that I mentioned to you guys. You will see that it goes through, for example, the properties of a parallelogram, which is one of the shapes that we didn't have an opportunity to discuss. It labels the shape very nicely, and you can see the markings that we used in today's lesson, right? It talks about 2 pairs of parallel sides, opposite sides being equal in length, and opposite angles being equal. That's quite unique to rhombi and parallelograms. So I would recommend you guys go and use this document and read through it carefully. Again, most importantly, please be careful of the word bisecting. Okay. I do believe it might have been misused once or twice by mistake, and we're working to just quickly change that. But be aware of it in the back of your head. Once you've gone through the entire document and you're comfortable with the properties of all of these shapes, go and test yourself. And you can begin working with different angles, right? If you feel comfortable with doing this. If not, we are going to discuss the fundamentals of calculating angles in geometry in a future lesson. Today was just about understanding what properties of shape are and the words that we use, because it's definitely a section that's got its own kind of lingo. All right. So you can go ahead and try these first 4 quizzes that you see at the top of the page here. And I hope that this will give you guys a good sense for where you're at with this topic. Guys, even if this isn't necessarily in the test that you have coming up right now, I promise you that knowing the properties of your triangles and quadrilaterals will benefit you as you move forward. Okay, there's never a bad time to learn this information. So we'll get to similarity and congruence quite soon. We're not there just yet. But guys, now you know where to find these quizzes. I would recommend you go and make use of it. Test yourself, see how much you understand. If you guys come across questions that you don't know how to answer and you'd like a little bit of help with it, you're more than welcome to come and speak to me about it whenever to have your next lesson, which is going to be next week, Tuesday, again from 5:30 to 6:30 in the evening. So, grade nines, that really is it for today, guys. I hope that you got some value out of today's lesson. We will be moving forward with this topic, like I said again, next week. But for now, we've discussed more than enough information for the last hour. So please remember that you can watch the recordings of these sessions on Facebook or on YouTube. It's completely up to you. And if you have questions after going through quizzes or documents on iRainbow, you're more than welcome to ask me about it next week when we have our next session. All right, grade nines. Guys, that's going to be it for today. I appreciate you attending, and I hope that I was able to answer some questions for you, even if you didn't ask them in the comment box. Um, but like I said, I'll speak to you guys all again next week. Please look after yourselves and keep warm. I will chat to you all again next week. All right. Thank you so much, great. Have a fantastic evening.